We are live in the Asia Tech podcast studio. This is Pitchdeck Asia. My name is Graham Brown, joined by Stuart Kerr from Rock Human Devices. Stuart, welcome.
Hi.
Good to have you here.
Yeah.
So,
good to be here too.
Well, it's great to have you here. You are bringing one of the first show and tells to Pitchdeck Asia.
Yeah, right.
Device. So we're going to talk about that.
Sure.
Maybe just a quick flash of it. Give the audience a glimpse of what we're going to look at. There we go. Yep. There you go. We're going to dive into that, the world of medical devices.
Yeah.
And we'll look into what exactly that is in the market we're in, the problem that you're solving.
Mm-hmm.
A little bit of background first before we dive in, Stuart. We're here in Singapore. You live here in Singapore, but originally from...
I'm originally from Scotland, in Glasgow.
Yeah.
And...
You've had a bit of a journey, isn't it? You didn't just go from Scotland to Singapore.
No, I went to Japan first. I went there to study in the 4th year of my 5-year uni course.
Right.
I was doing electronic and electrical engineering, and I went to a robotics lab to do some cool thing where they get robots that fire like a launch mechanism that grabs onto trees, and the robot swings over a valley or something.
That sounds awesome.
It didn't work out that well.
It was a good idea.
We managed to get it to crawl across like the lab floor, and then the project was pretty much done.
Wow.
And then I worked in Japan for about a year to a year and a half, roughly. And then I got fed up with the working culture, so I just moved to Singapore.
Yeah.
And I joined a startup there. And that was great. It was a 3D printing startup called Pirate 3D. And then that didn't do so well towards the end. It basically crashed. So after that, I joined Dyson for 2 years and worked on the Dyson Supersonic for a little bit,
which is the
hairdryer.
Yeah, the blade.
The hairdryer with the whole
yeah, looks like magic.
Yeah. And the purifier fan. So I worked on those at the point where the design is mostly complete, but you've just got to work out how to get it to making, like, to go from making just 5 of these machines to making like 500,000 or like 5 million of them. So like, how do you scale up? So that's the kind of thing that I worked on.
Yeah, that's great education as well.
Yeah.
Because you're working with Dyson. I mean, he's a great inventor, but he's also a good executor. He's not the executor. He's surrounded by great executors, right?
Yeah, exactly. Yeah,
he teaches you a bit about how to build a business, right?
Yeah, exactly, and like how to go from those like 1 or 2 working prototypes to something that you can actually mass produce. Yeah, it was really cool. And then after that, I kind of got I didn't like the larger company thing because there's like Dyson's about 6,000 to 7,000 people now. It was growing quite a lot, and I don't know, I felt like a tiny grain of sand on a beach type of thing. You just felt like quite small. It's just like inevitable about part of being in a large company. Just kind of fell out of love with that, and just decided I wanted to start my own company, and that's basically what I've been doing ever since.
So did you decide to start your own company before you had the idea for the devices we're going to talk about today? Which sort of came first? Is like, there's a need for this, I need to make this, or what can I go out and make? Where did it come in sort of the odyssey of Stuart Kerr?
This thing was just a hobby in my spare time, and then I got somebody to try it out, and it really worked for them, really, really well. They said it's the best thing that they've ever tried, and they've been to audiology consultations and everything. And then I thought at that point I had to I think it was like a week later I just handed in my notice.
Wow.
I thought, well, I mean, I've saved up enough money, and so I'll quit. I'll try it. I'll put my full time into it. Try to find investors quickly, as quickly as physically possible. And we did, yeah.
Well, we'll talk about your journey as well with Rock Human Devices, where you are, because you're a funded company.
Yes,
you've got some interesting backers as well. We'll talk about that as well.
Yeah.
So you're putting the team together.
Yeah.
I mean, you have been in development for quite a long time because of the nature of the product that you're developing. So let's talk about that now. Let's put that on the table. Maybe you can show us the product first.
Yeah.
Tell us what it is. You've got 2 here.
Okay. So
cameras here. So maybe just be, wary of just trying to get that in the shot there so people can see. If you're listening at home, maybe we can sort of talk through what it is as well.
That's
so
fine.
What have we got there in your right hand?
Right, okay, so what it is basically a pair of glasses. This is one of like 2 or 3 different styles that we're basically testing with right now. What it does is if you have a particular type of hearing loss, this can make you hear, whereas before you would have had to require medical surgery in order to make yourself hear. So basically, about 4 to 5% of people in the world have hearing loss, and about 20 to 25% of those people have something called conductive hearing loss. The best way to explain it is that everything inside your ear is working, but it's as if there's a blockage for the sound to get to the ear. So you may have no eardrum, you may have no hole in the side of your ear. You know, one of our trial users, he's got basically, I mean, if you look at his ear very closely, you'll notice he's got no ear canal. It's just like closed shut.
Right.
So no hearing aid is going to work. Because like,
are they born like that, or is that something
yeah, just a random birth defect. The bones, and another trial user, she's got like the structure of the bones in her skull have basically closed shut her ear canal. So she would have to get like $200,000 reconstructive surgery to get that done. She risks like a very severe brain infection, meningitis, all these risks are on the table just to make her hear again. So the only way that these people can hear is if you can not use a traditional hearing aid like you normally see, but if you can vibrate the skull bone behind the ear, right? Because if you can tap this or vibrate it with sound waves, what happens is the sound waves can travel past the blockage and reach the ear that's working perfectly fine. Yeah. What's usually offered to these people is something called a bone-anchored hearing aid, where they actually drill a hole into your skull, screw a little screw into it, and then they get this little matchbox-sized box that basically clips onto that screw that permanently sticks out from your skull.
That sounds terrible.
Yeah, like you can go and Google it. It's called a bone-anchored hearing aid, and it's pretty horrible.
I mean, it seems in this day and age that seems pretty brutal.
I know.
From a different era.
Yeah. So the reason why that's such a popular option is, well, I mean, it's not a popular option. The sales conversion rate is something like 1 in 2,000 to 1 in 5,000 people that qualify for it and go to try to get it done. That's about the percentage of people that actually end up going for it. Yeah. And it's about $25,000 for the procedure and the devices and all that.
So people would rather be deaf than have that stuck on their head.
Especially because that type of hearing loss, 95% of cases, it's actually only on one side. So you can technically get through life, but it's pretty hard. Like you suffer not being aware of your environment. And so what we've developed is something that works equally as well. And it is super, super stylish. And actually, we've solved some of the major engineering issues. I can't talk about the solutions just now because we're actually filing the patents by the end of this month.
Right.
But it's pretty damn cool.
Let's start by. Can you hand them over? Can I have a look?
Yeah,
here?
Sure. So this is just a mechanical mock-up. So we just so we just purchased an industrial 3D printer. So we've been iterating the design like crazy. Right. In the last week and a half.
Yeah, because I remember when you showed me some months ago a different version of it.
Yeah, so that's the last version of the prototype that was working.
Wait, which one? This one here. I'm holding up now. So what we have here, if I can just describe to those, if you're just listening to the podcast, it looks like a stylish pair of glasses, as you say. At the end, you've got where the foot of the glass is. What's that leg?
So the legs are the temples of the glasses. So the part of the glasses that kind of bends round behind the ear.
Yeah, right, which would normally just sort of clip back in. You've got like a tiny box here.
Yeah.
And that sits on the bone.
Yeah, so the surface that you can see there, that actually presses against the skull with a calculated amount of pressure. Right. So, and then basically, if you're deaf on the right side, then we'll basically have the sound coming in on the right microphone. Yeah. And our digital signal processing algorithms will sweeten all the sound up, and then it will retransmit it through the skull bone. Yeah. And there's no surgery, there's no anything at all. You literally, like part of the demo is, here, try this, and they put it on, and it turns itself on, and you can just hear.
So the sound which is actually out there has to be converted in a way through an algorithm to pass through the skull?
In a way, yeah, because there's certain problems that are associated with hearing aids. You've got things like wind noise. Yeah. You've got things like, if you're wearing a hearing aid that amplifies the sound of everything, it also naturally makes your own voice sound way louder to you.
Right, like a duplex effect.
Yeah. Okay. So it's like you can hear yourself talking 2 or 3 times as loud as before, and it can be quite distressing. So with part of our really, really cool tech that we're going to be launching when we launch is going to basically solve those problems.
All right. So it's like in studio terms, we call that a mix minus.
Okay, right.
There you go. It's like if you feed something back into the mixer, you actually take out the original.
Yeah, if you invert the wave. Yeah.
There you go.
Yeah. So
interesting.
So
all that sits in this little box here.
So just the part that vibrates the skull is basically in that little box, and then in the next prototype that you have in your hand, about 1/3 of the space taken up in one side will be just the electronics, so everything like the battery charger, the digital signal processor, everything. There's going to be some like severely advanced tech.
This is a lot.
It's going to go into this.
One.
Yeah. Right. That's one of the other styles that we're going to be testing as well.
Yeah.
We're testing different sizes as well, just to make sure. Yeah.
Right,
and we've now got hinges. We've now got directional microphones. We've now just got we're iterating the design again. So like by tomorrow morning, I'll have new parts again.
So without going into too much, like, secret data about what exists inside of this, just in describing what is inside of it. So you've got a vibrating mechanism inside. Yeah. The bit that curls around the back of the skull, which would have been in the box in the old days, that horrible thing that people drilled into their head.
Yeah, exactly.
That replaces that effectively.
Yeah, exactly. So by having glasses, you can actually apply enough pressure.
Right. Yeah.
That so that all you need to do is put the glasses on, and then the thing that vibrates the skull just presses just the right force. Yeah. To allow the sound to like very efficiently be transferred into the skull. Yeah. The solution to that before was drilling it into the skull. That's like 100% efficiency almost. Yeah. But this is quite a different take. So.
Right, but there's no surgery.
None. Like the demo is try it on, and within 2 seconds you can hear.
Wow. So go back to that moment when a week before you were leaving, and you had that person come to you and say, "Hey, look."
Yeah. So
tell us a little bit about that.
Yeah. So I basically I was working on the prototype at the weekend. And I literally just got the software working on it. So like I was writing the software to get the signal processor thing to basically just come alive and basically work and take the sound of the microphones and put it out to the bone conduction transducers. And I just got it all to work. I was like, oh, finally. I've been working on it for like 2 weeks straight because I'm not a software guy really. Right. But I'm just managed to get it working. And then like within half an hour, I got a message from my flatmate. He was saying, "Look, my friend who is my flatmate was a head chef. He was bringing a friend from America to work as a chef in his kitchen, and my flatmate asked me, hey, just to let you know that somebody's going to be coming to the house. Can you like help him and give him a key and show him the bedroom and everything?" I was like, okay, cool. So maybe half an hour later, he comes from the airport. This guy. And he walks in, and then my entire table is almost like an electronics lab, like right in the middle of the dining area. And I've got oscilloscopes and wires and power supplies and just stuff everywhere, right? And he, after he kind of unpacks and he comes over and chats to me, says, "Oh, okay, so what are you working on over there?" And I said, "Well, I'm working on a hearing aid. I don't really know if it's going to work or whatever, but I just got it working in like the last hour or so." And I said that. "Oh, that's awesome. I'm deaf on my left side." And I was like, "Oh, that's awesome because I've only got it working on the left side so far. I haven't got the right side working yet." And it turns out he's the perfect candidate because he has that hearing loss that I talked about. He's got no eardrum. He was just born without one. So the sound just doesn't hit anything. It's like just dissipates and that's it. It never reaches the part of his ear that that can pick it up and take it to the brain.
That's a weird twist of fate.
Yeah. And then, very weird.
Coincidence.
Just like.
Do you read much into that?
No, I don't. It's just
probability.
Yeah, it's just pure coincidence.
Right, okay.
Yeah, I think so. I mean, like 1% of anybody you meet will have this, so like it's not.
But you happened to be there whilst you were building it.
Yeah, like an hour and a half after I got it working, roughly.
You didn't turn up 2 hours before and say, "What are you working on?" "Oh, I haven't finished it yet." "Oh, okay." See you later.
I know. And then he tried it and he was like that. Holy shit! I mean, like, there's a video of it on YouTube somewhere.
Wow. Yeah, we put a link to that in the show notes. Sure. Yeah, that'd be cool.
Yeah.
So
he said
like?
after.
So tell us about that experience when he put it on.
Yeah, I didn't know if it was going to work. I was super, super nervous. I delayed it for half an hour. I was like, "Oh God, this is going to be like all this effort, and it's going to be for nothing."
But you weren't ready. You weren't prepared to give that to test to somebody.
No,
right?
no, I wasn't. And then he tried it.
Yeah,
and even in the video, you can see like the wires are like sticking out of the frame. And he tried it, and he was like that. "Oh shit, I can hear." And he thought like his brain interpreted hearing like that for the first time as like after 29 years just pulling an earplug out of his ear finally, because it had that sensation that like his brain didn't know what to do with it, so he kept doing this thing with his jaw. He was like, ugh, like almost like he needs to click his ear. Like when you
get off the plane.
Exactly. Yeah. So when the pressure changes on a flight, you kind of like 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 that was the sensation that he felt. And we played some Bob Marley music, and like we had a couple of whiskeys, and he was just like, this is so cool. Like, I was trying to talk to him to explain him what was going on, and I was just so distracted by the fact he could hear. I'm like, oh, sorry, man, I'm not even listening to you. He's like, oh my god, this is so.
Yeah.
And I thought, okay, there's probably something here. So I looked into it, and I decided, well, I wanted to kind of go and do my own thing anyway. This has to be it.
Well, why do you?
So I just quit my job.
Yeah, right. But why do you think that was right at that right time to make that? What was it, tell us a little bit about how that made you feel. When he gave you that impression, that sort of feedback of this is what it's done for me. And even though for you it's still very raw,
yeah,
you weren't even ready to test that. What sort of impact did that have on you? Particularly as well, you sort of mentioned that you'd been in the corporate world. You'd done your schooling in design and engineering with some great names as well. Now you'd made something yourself, purely on your own. And it was a one-on-one, and there you were with somebody using it and giving you direct feedback. That's a completely different world, isn't it? Yeah. For you, how did that make you feel?
I really liked it because I thought, finally, I'm doing something that I can control, right? So, I mean, I'm not a control freak, but I don't like to be so far away from the end user and so far away from the customer and so far away from the people that make the decisions. I just don't like it. Because... yeah, I mean, I don't know, it's just a personality type thing, I guess.
Well, you want to make something that's meaningful and feel like what I'm doing is making a difference.
Yeah, that too, because I mean, it didn't take that long to get the first horrible prototype to just be up and running, just to emit some sound, right? It didn't take that long, and it already had a big effect. I'm like, oh wow, so I've been working in like companies for years, and I'm one member of a 12 person like electronics team launching a product out, and nobody knows your name, and I probably don't even believe in the product either, and it's like, it just kind of like I was pushed out of a company because of that, and I was drawn towards this new thing because of this. So it was like I was pushed and pulled towards it kind of at the same time.
So when you decided that you were going to do this and you were going to build this product and you're going to set up this company, was the idea to build this product, or were you sort of thinking medical devices? I'm going to go and...
No.
What was the idea?
No, so I'm not drawn to medical devices. They're a freaking nightmare to design and develop for. You've got to go through certification procedures. There's very few, very large companies that are they're competing. It's not like...
and you're not an insider in that world either. That's the important thing.
Yeah, I'm not.
You don't have 20 years of experience or 20 years of relationships in medicine, right? You're not bringing like pharma relationships and so on. So that's not your world.
Yeah, but I kind of get by that by having an incredibly close relationship with the trial users. So we've got about, just organically, we've basically grown from like one trial user to about 50 that are on a list just waiting to try this. We may do paid trials at some point soon. Like quite a nominal fee, maybe $200 or $300 USD, just to kind of cover the parts of the prototype.
They pay you.
Yeah, we're planning to do that probably next year, so that we can also show people like, look, people are willing to give some money for it.
Yeah.
I actually kind of forgot what your question was again.
Well, exactly. So we've come on to the point about economics. I mean, I was asking you about what your goal was, whether you were there to build this product, or you thought, I'm going to go in and create this mega brand in medical devices, and we're going to change this whole sector. But it's just like I'm focused on this one problem right here, right now.
Well, yeah, I mean, it's also quite a good way to prove a point, is that medical devices can be super stylish. Yeah. Right? Eyewear used to be really, really like untrendy and unfashionable, and probably, I mean, and then companies maybe like Ray-Ban or certain styles or certain public figures and all that. Like Malcolm X definitely made eyewear super stylish, especially that kind of like 1950s look. Yeah. Which is going to be one of our designs as well. It's like medical devices. When you think of a hearing aid, it just sucks, right? Yeah. It's like it's this skin-colored piece of plastic. If you drop it, it breaks, and then you need to buy a new one for like many, many thousands of dollars. If you want to change anything, usually you need to go and get it programmed, unless you've got this super advanced $10,000 one that works with Bluetooth. It's just and it just kind of sucks.
Why?
You know what I mean?
Why are they like that?
I don't know. I don't imagine that medical device companies are like inherently stylish.
Yeah.
I think
it's solving a problem, and the problem is not how I look, is it? The problem is like I have a functional problem in my body somewhere.
Yeah, Yeah, it hasn't been up until now. So basically, the way I think about it is, like you've got to solve the actual problem first from like an engineering point of view, and then focus on the aesthetics later. And I think now people are like, Google Glass didn't take off because it looks like something else. It doesn't look like a normal pair of glasses. It doesn't look socially acceptable. I think now it's time that this problem is solved. You know what I mean?
So do you think? I mean, obviously you are approaching it from fundamentally an engineering problem.
Yeah.
And then it's how do you make that in a way that people could be proud of wearing these devices and showing them off, not sort of hiding it.
Yeah, exactly.
Like, why are you all sort of like lying like that, Stu? Like, oh, I've got a big box stuck to my head. So you don't want that. And as well on top of that, then I guess now you're talking about introducing more sort of fashionable lines to this as well.
Yeah.
So that people will feel not uncomfortable in any way having these devices, which is great.
Yeah.
And it doesn't become an issue, right? It's not an issue in their lives, like a hearing aid as well. I mean, I want to ask you, because I don't know enough about conductive hearing loss, but I imagine with conductive hearing loss, it's different to normal, whatever you call it, hearing loss, which is that it's not necessarily an age-related thing as well. So,
a very, very small percentage it can be, but generally speaking, you can say it's not. It's usually a birth defect or injury, and I'm sure there's a doctor somewhere that's listening that's like screaming down, like his phone at me. But
you could be born like that rather than hearing loss generally, increases as you get older.
Yeah,
right.
So that's the more common type of the other type, which is called sensory neural hearing loss. It's with the nerve that takes the sound to the brain weakens, or that whole path is like there's something wrong with it.
Yeah.
Conductive hearing loss is a bit different.
So I guess as well, there's a market of people who, I mean, old people with hearing aids. That's the natural assumption, and you see the adverts in the newspapers as well. The ones I mean, where it's like it's very functional.
Yeah, and you see, like the white-haired grandmother with her grandchild, and it's, we can hear each other again. It's
exactly. But what about the kids and the teenagers?
Yeah.
Right? And when you see kids and teenagers with hearing aids, it's like they're very conscious of it.
Yeah,
right? And they're going to get teased.
Yeah, of course they are.
Yeah,
because I mean, like when you're very young, there's two things that are happening. It's that you're forming your identity, right?
Yeah.
And if you've got something like hearing loss, it can really affect your things like if you feel like excluded from groups or and also your ability to kind of get on in life, like in the classroom or just like going out and playing games or whatever.
Absolutely.
Having hearing loss literally puts a boundary around you, and it's very difficult to communicate with any of your peers unless they also know sign language or something.
Yeah.
It's a big issue. So like we're also working on child sizes for this, because I got an email from a mother. She's got a kid that's got so her daughter needs bone anchored hearing aids because it's all that's really available. It's all that's really covered by the Singapore government, which is fine. I mean, it's awesome that they cover it, right? She's got I think a birth defect where like her ears could have maybe closed shut on both sides. There's like a bone structure issue or something. So basically she has no ear canal on either ear. So the only way she can hear is with like being covered in hearing aids. So she's got one that's bolted into the skull on one side, and the one that she can take off that almost looks like a 1980s like Walkman headphone band to press against the other side, so that she's got like hearing on both sides.
How old is she?
And it kind of sucks. I think she's like 7 or 6 or something.
Yeah.
So yeah, her mum kind of reached out to me and said, like when she's off, like for the school holidays, can I bring her down and maybe see what we can do? And I'm like, because we're gonna
awesome.
Because we're gonna immediately do child sizes like as soon as we can.
Yeah. Okay, well,
so,
let's talk a little bit about that, because I mean, we're going to talk about the trials as well, and also the economics of it all.
Sure.
Because in the context of like medical devices, and if I can, glasses are effectively like eyeglasses are medical devices in a way.
I suppose they are. Yeah.
I mean, they're there to,
they're regulated in that way. Yeah.
Right. Exactly. They're there. I mean, you have to be an optician to prescribe them, I suppose. Lenses at least. Right? Yet, for example, my son's 12 years old, needed a pair of glasses. And for years and years, it's like, I'm all right. But he's always squinting, right? Like, why do you keep squinting? No, it's nothing.
Yeah.
But then, actually, you need a pair of glasses.
Yeah.
We took him to an optician and got him a cool pair of glasses.
Yeah, exactly.
And he loves them.
Of course he
does.
And
it's like, it's totally different. And you think, why can't it be like that? Because now he's like, actually, I look pretty cool with him. He's doing his hair as well now.
Yeah.
And they look really good on him.
Yeah.
So, why doesn't, when it comes to sight, we've got it on that sort of level where it's not an issue.
It took a long time. I mean, it took for them to focus on the style, and you know what I mean. To like suit different head sizes and like reflect people's personalities and stuff.
Right. Yeah, the NHS glasses.
Oh, yeah.
That was it.
Those, they're horrible.
The tortoiselle glasses or whatever.
Yeah, you know,
so the National Health Service glasses, which were prescribed, right?
Yeah,
and that was a bad look, right?
Yeah, really, really bad.
Well, obviously we're in the medtech space, so we can't not avoid the issue of regulation. And, you know, I don't know what the equivalent of the FDA or whoever they are here in Singapore. So let's talk about this in the context of how does this sort of fit into, you know, regulation, licensing, and so on.
Yeah, so what I'm trying to do is I'm trying to start the culture of the company to make sure that it's very two-sided, right? So we've got to have the free and liberal kind of design approaches and stuff. Design area that looks super stylish. Put as much technology as you can to solve the problems in it. And then we need to have a separate side of the company that's like basically providing the platform for these people with almost like giving them, you know, like a list of like plastic materials that are already medically certified and kind of giving the resources to the design team so that they can basically work freely in like
in the parameters of what is allowed.
Of what will eventually be needed when we go for certification. So like, it's not.
So what is needed certification wise? What do you need?
So what we're going to do is we're going to get a European medical device certification. So it's a body called CE.
Yeah.
So I mean, you've probably seen
the little marks. Yeah.
I mean, I think it's on the back of my phone and all that.
Yeah.
CE, and it's got different levels of medical device. So usually there's we can self-declare that we can say, yes, we've met all the standards. It's actually a self-declaration standard, but that doesn't sound right, does it?
No.
I can say that I'm a safe medical device, right? But then would you trust a manufacturer that just said, yes, it's safe, I promise, and then get that pacemaker put in? It's like, no, it doesn't sound right, does it? So hospitals, audiologists, any country that's got some kind of authority on what medical devices are used in the country will request that you have had a testing, like a reputable testing body to do all the tests for you and provide the reports that then you can use as for your self-declaration. So that's one of the companies is TUV. Like you might see it in the back of like motorbike helmets and stuff like that. There's a company called TUV. It's a German company. They're all over the world. They do certification for probably every single country. So we're going to basically use them. They're going to tell us what standards that we need to design our product to, whether the plastics that we use can be like medically certified and all that. We zap it with like 16,000 volts of electricity just to see what happens to it as well. There's lots and lots and lots of tests that we need to do. It needs to meet like hearing aid test standards and all that as well. It's quite a boring topic actually, but it's one of the things.
Well, it's what an investor wants to know is that have you thought this through?
Yeah, we have. Yeah.
I'm sure you have. I'm not. The point is that what exactly lies between making the prototype, making the product, and then selling it to the customer, right? So.
Round about now is about the time that we really need to look quite deeply and seriously into designing for medical device certification. So we know the standards that we eventually need to comply with, so we need to start designing for that, right? So that it includes like the software, like how does the device respond in certain actions or certain whatever. It's all got to be basically certified. We need to like start designing that from now. We've got we're past the working prototype stage. Now we're kind of looking at, okay, how can we certify it and how can we manufacture it?
So how will you then actually sell it to the customer? How do you do it? Through retail, through opticians, through how will it work?
Not retail, because some hearing aid companies are selling these devices called personal amplifiers or personal amplification devices, and because they're calling it that and not calling it a hearing aid, they can basically not bother certifying it as a medical device. They can just put, like a CE stamp on it, and then like that, right, okay, fine, just try to sell it on Amazon or whatever.
Right, that's like your food supplement, isn't it? Rather than selling a health product,
Yeah, exactly, yeah, but then still putting like steroids into the supplement, you know what I mean? Like, it's like, it basically is doing the job, and some people try it, but there's... I'm a bit against it from like an ethical point of view. It's okay at a prototyping phase, But when we launch the device, it really needs to be a certified medical device, and you need to go and see an audiologist because there's plenty of reasons why. It's like you, as a person with hearing loss, are not really the best person to decide what the best solution for you is. You may have a tumor growing in your ear, and you better go and see an ear, nose and throat doctor before it travels to the brain, rather than just going to Amazon and choosing a personal amplification device.
Right. So would these have to be prescribed?
Yeah.
Audio? Okay.
Yeah.
So you would have to have that come through, the medical.
Yeah. So our orders would
channel.
come through audiologists,
right?
And the payment would come from the audiologist or the insurance companies.
Yeah. In Singapore, or is that going to be in most markets like that?
So that's pretty much most markets.
Yeah.
So the idea is, so that kind of brings me on to the next thing, which is like we're going to be manufacturing this thing quite differently. We're looking very, very strongly looking at the possibility of doing additive manufacturing.
Which is what?
Which is not spending millions of dollars on injection molds, but spending a couple of $100,000 on a range, like a cluster of industrial 3D printers. We can then, so let's say if a customer's order comes in, they've chosen the panto style of a particular size and all that.
Yeah.
And we've got the lens prescription. What we can do is we're aiming to design a production line, and we're kind of doing that right now, where we can basically think, okay, go. So then we print the part. Within a couple of hours, the part's ready. We tumble the part in a huge drum that basically has, like pellets and sort of like sanding material to basically create this super polished, smooth plastic. Yeah. So it comes out the printer a bit rough, and then the end result is a super, super smooth and super strong part. And then we assemble the part and ship to the customer or ship to the audiologist within about 24 to 48 hours. Most people wait a very, very long time for their hearing aid. So if we can basically remove as much work for the audiologist to do, like we'll program it for you as well, like before we, like before it ships. That's the idea. It's that you can be like an audiologist can be like pretty much hands off, like just like get the hearing loss report, make sure that this device is what they're suitable for, and then we can do the rest. We can send it to the customer. We can handle the warranty. You don't need to go through the audiologist. And if you want to reprogram the device for the customer, you can do it over the cloud. So if it's connected to their phone, basically the audiologist can like update your hearing loss report, and then the person's hearing just gets better. You know what I mean? So it's quite different, because usually hearing aids are mass produced. To get injection molds done that meet medical standards, it's so freaking expensive, because we just got it all quoted, and it's like, oh, this is just a nightmare. Right,
but additive would work.
Yeah. So
okay.
the thing is the choice of the plastic material, and what we use in the process, like to process the part to like polish it up. So all that would have to meet the standards as well. But that's the conversations that we're starting to have from next week. So we're basically planning all this.
Okay.
It's like a dream production line.
It is, but it's not unrealistic.
No, it's not. It's totally doable.
And let's not forget,
and it's scalable. It doesn't need a lot of upfront investment.
Yeah.
It's perfect for a startup to kind of like get into manufacturing and get some money into the bank.
Yeah.
We don't need to put ourselves in debt or get like $10 million of investment just to put a product on a shelf. And if we want to introduce, and for every new style that we would have to make, if we did it injection molding, you have to pay to get an entire new injection mold made. Yeah. You're talking about $100,000 to $250,000 for one mold, right? And if we want to save money on the mold, we basically have to waste plastic, because we have like all the sizes of that style.
Yeah.
Being produced in that same mold, but then we throw away the plastic that we don't use. So it's like
hugely wasteful. Yeah,
it's very, very wasteful, very power intensive.
Yeah.
Whereas we can introduce a new design digitally. It's like, okay, now we've got, like a Nomad style. It's available right now.
Yeah.
And if the customer requests that style, it's just printed, and within 2 hours we've got the part. We don't need to, and it's no extra investment. We're not spending any more money to give more styles.
Yeah.
It's just, that's kind of the way that it should be, I think.
Oh, absolutely.
I mean, it's the model that fits what we're trying to do.
Yeah, and I think for those that are listening or watching, that let's put this into context, because I know it's disruptive, and you are really you're it's an engineering approach, but you're really focused on the end customer in terms of what they want and the experience, what makes them happy, and you know what is good for everybody, which is great. But let's put this into context as well. I mean, you know, and we haven't really talked a lot in depth about this. Your background, you know, the reason why, who could pull it off? I mean, we'll talk a little bit about the team, which is, you know, for the large part has been you, and we'll talk. Obviously, now there's two of you. We'll talk about that in a minute. Your background, obviously, you've worked for Dyson. You talked about some of the, you know, projects that you've been involved in Japan, for example. You also worked for the Japanese equivalent, or if that was the same project, of the CERN project in Europe, the Hadron Collider, right? So you haven't just sort of gone in and like messed around with like little things in labs. You built big things as well. So very complicated, many moving parts. Large, you know, firing beams around I don't know what exactly goes on there.
Basically is that, although what I worked on was the power supplies that basically, so they were used in those projects. I think it was like one of the machines that we all designed was is now being used in CERN, and another one has been used in Super KEKB.
Right,
which is the Japanese. It's like a linear accelerator, so it doesn't go around in a circle, it just goes like straight. So basically for the one in CERN, we basically designed the power supplies that power the electromagnets that steer the beam into a circle. Because if you didn't have these steering magnets, the beam would just go straight and it would crash into the wall of the collider.
Right.
So we designed the power supplies, like super stable supplies that basically kept this beam in the center of the tube as the beams went round in a circle.
I love listening to it. Yeah, I love listening to it because it's like, I feel like I just can sit and listen to this because it's just fascinating. It's like, but I guess the point we want to get across is like, you know, you've worked on seriously complicated projects. So you know, when you talk about, for example, additive manufacturing lines and the process, it's not like you're talking about something way out of your scope.
No, it's not. It's very, very doable.
Right, exactly. So and you understand what's capable as well. If you can fire beams around corners. You know, I'm sure
I mean, it doesn't qualify me to manufacture medical devices.
No.
But
it's as an engineering problem. Yeah. So, you know, you weren't sort of manufacturing like small Matchbox toys and then said, right, I can go and do this now. It's like, you know, you've dealt with large projects. And I guess the point is that these are complicated projects as well with many moving parts. You've got that going for you. You have investors. Right.
Yeah, so we've just closed our second funding round. We had our first funding round it was about, I think the total was actually 105,000 Singapore dollars. And we just closed another one 3.5 months ago. I think the money arrived in the middle of August or something. That was 420,000 Sing dollars.
Right, so it's about over 500,000 600 that you've done.
Yeah, in total, yeah, about 500 and, aye.
And can you talk a little bit about who your investors are? I mean, without giving too much away, but
so I won't name them because I don't know if I've actually got the permission yet. The first investors,
but in terms of their backgrounds, I think that's important. You know,
very, very mixed. So my first investors, of my first investors, they're all from Stuttgart, right? And one basically is a managing director of a company that sets up call centers in India and the Philippines and other countries. So he was the MD of a German company that does that. Another one is one that designs like websites and apps, and he now is the co-owner of like Stuttgart's best bar or something like that as well. So he's just, you know, like he does
angels.
A little bit of everything. And I can't remember what the third investor does.
Yeah, it's institutional investors now.
So on the second round, so my first round was actually from 2 small VC firms, which is weird, and then the second one was from angels.
Okay.
So it doesn't have to be like
that's interesting.
It's not set in stone that your seed or your pre-seed is angel, and then you have to go to like corporate investors. You know, like when you get above a certain amount, you know, there's a lot of people that have just got too much money in the bank. And then they kind of don't know what to do with it.
Okay, so you've got those guys behind you, but also now your team. I think it's important as well because you've raised this money, you've built this, and for a long part of your story, it was just you, and you've done very well outsourcing, getting people to work for you. You know, without actually sort of bulking up the payroll. Now there's 2 of you, so you've sort of run it very lean as well. Very conscious,
quite frugal.
Frugal.
Yeah, it's because like a lot of projects just kind of. Like especially when they're engineering led, like they're led by a team of engineers. Yeah, they get stuff working very well, but they've also got a tendency to go down a rabbit hole. And like like feature creep and like
Absolutely.
let's add this and let's add that and let's do this, and it's like no, you can't do it. You've got to like choose very, very specific things that you want to do, very, very few and very specific things that you want to achieve within a certain amount of time. Like for the $420,000 that we raised, the purpose of it is to take the prototypes to the next level. So it allows us to do things like buy a couple of industrial 3D printers, prototype the hell out of it, get it to the point where it's like a polished product that works well enough for now, with all the new technology that we may need to patent, and to file the patents or to file the PCT application. That's the specific things that we need to do with that, with the money that we've got right now. So I don't need anybody more than an electronics and software engineer. That's all I need right now. So I'm not going to spend lots of money and hire an industrial design engineer and a software engineer and an apps guy. Like, it doesn't make sense right now.
Yeah.
We don't have enough funding for that.
Right.
I'd rather have the runway and work as a very, very close and small team aggressively to get the product where it needs to be, rather than hire too many people and try to get too much done in a short period of time.
Absolutely.
That's my philosophy on it anyway.
Well, it's certainly a philosophy that people will be happy to hear.
Yeah.
So what comes next?
So basically what we need to do, so we've, by Monday, I think we should have actually filed the PCT application.
Right.
Or no, I'll be getting the final draft of it, and then I approve it, and then it's going to be filed on Wednesday or something like that. Basically by the end of the month. So we get the results back for that in March and April. That kind of gives us more credibility that our technology can be patented, right? So that's what that is. It's a report that says yes, you can patent all of this if you want to and you can afford it, right? So the next stage for us is basically to raise money so that we can file the patents, hire more people. So I actually want to hire a CEO, right? Somebody that's way more business minded than me that can just run an operation. Yeah. And I want to kind of stay leading the engineering side of things because that's what I'm, because that's more what I'm good at. And to push all the devices through the medical device certification process, plan the manufacturing, and set up the first small production line and get that certified as well, because the production line has to be certified. That's basically what we're raising for next.
When do those conversations start? When do you start in earnest now, start devoting your time?
Seriously, I'll be asking from about April of next year.
2019?
Yeah.
And
that's when the conversations really should start. And ideally being realistic, we want the money in by the end of the year. If it happens sooner, great, fine. We just eat into less of a runway. But a runway will last until July 2020. Right. The way things are going now, that's if we're still going to spend an additional $50,000 on R&D, which doesn't look likely because we've already spent a good chunk on it. Even at that, we should be basically on track to last another 20 months from now. Yeah.
Right. So that would be a Series A?
Yeah.
Right. And are you able to talk about check size or roughly?
Yeah, we need, I was pricing it all out in the last week. Basically, we need $2 million. That's Sing dollars. Sing dollars, yeah. So
$1.5
US. 1.4, 1.5 million US. Yeah.
Okay. And that will be, as you say, for all those things, CEO, certification.
Yeah.
And just to then build out those products.
Yeah. Just to get it so that it's done and it's finished. You know what I mean?
So let's talk a little bit about the CEO, because it's interesting that you talk about that. And I know you've worked at Dyson as well, so obviously that's left an imprint on you. And, it's easy to be the inventor CEO, never necessarily the best thing, because sometimes people who are great engineers aren't necessarily great CEOs and vice versa. So you've made a conscious decision.
Not necessarily,
Sometimes, yes. Not always.
Yeah, quite a lot of the time, no. I didn't want to start a startup, right? But it's the only way that I can actually design something and get funding. It's all that is to actually have a company. It's like, I need to have a company now. It's like it's like just
it
part
wasn't
of the process.
Goal, right?
No. Yeah. Like the goal was not to have a company. The goal was like, I would rather be doing this. Yeah. So I will just do it.
You enjoy making, designing, the challenge, the mental challenge. You need somebody who actually wants to build a company, who loves that aspect of it.
Yeah, and I think a lot of startups could do without that ego of trying to be the CEO or like just wanting to be the CEO of a growing company. Because if that's your goal, then it's going to crash to the ground because you've got to do whatever fits.
So what kind of person does it need to be? What would it be the qualities that you're looking for in that person?
I've not fully figured that out yet.
But would it be somebody from the medical world or the engineering world?
Somebody, yeah. So somebody that can navigate the medical world would be incredible. And there's there's not lots of people, but there's some severely qualified people out there.
Yeah. And would they be very much a front man of the business, like going out and like, you know, doing the public speaking and going and like, you know, doing the deals whilst you're sort of in the lab working away?
Well, I don't mind. I mean, like, I'm quite happy to. I quite like setting the culture and the reason why the company exists. I quite like being in control of that now.
Right. So you're looking for somebody who's more sort of managerial in that respect, who can sort of like build a business, run a business, look after all those kind of that sort of stuff. The engineering, which is a core part of the business, is that culture and the DNA of what you do, right?
Yeah. So I mean, and it's one thing that I learned from Dyson as well. It's like James Dyson isn't the CEO of Dyson, right? He's the chief engineer, right? Yeah. He's got he's got a CEO, a CTO.
So what does the CEO do in that situation? Just look after.
So, for example, probably. The last CEO of Dyson's job is a German guy. I can't remember the guy's name. His job, like his main like KPI was basically get Dyson to explode in China, right? Yeah. And he did it. So it's like get into that market, sell it, promote it, figure out what we should build and why, and just kind of. And then you can help to specify what the engineering team should do next, kind of thing. Yeah. I mean, it depends on the company. I mean, it depends what the goals are. But yeah, the CEO thing is not really for me. Like, I'll do it. I'll do it for now.
Yeah, you have to.
Because it's my company. Yeah.
You're doing everything as well as like
absolutely
making the coffee.
I'm the CFO. I had to. I messed up the accounts before the AGM. I didn't realize that you had to like reconcile your bank statements with your accounts. I didn't even know that there was a separate thing called accounts. I was like, wait, what? I've got to prepare this for the AGM? Ah, shit. So I had to sit and manually do everything over a weekend. I'm like, oh God, screw this. Like, I really want someone else to do this.
Yeah, well, that's good. I think, you know, the key lesson, obviously we're talking about it because, you know, there may be somebody out there who's watching this who, you know, there may be a conversation down the road. You know, or maybe a conversation you have and somebody goes back and watches this and said, okay, I want to find out more about Stuart and the team as well and your philosophy. Like, you know, what exactly do you have expectations for me? And that's why we're putting it out there. But also, I think it's important because you've already identified your strengths and weaknesses. And I think that's really important rather than be, I can do everything.
Well, yeah, I mean, I would rather be the chief engineer of my company and the company succeed because I hired a CEO at the right time, rather than me pretending to be the CEO of a company when I'm just the worst at it, let's say, and I just crash the company into the ground. Like that wouldn't make sense. It's quite a sensible thing, I think, for me and the company to actually hire a CEO. But I would still be the majority shareholder. I would still be effectively in control of the company. You know, I could get rid of the CEO if it isn't working. It's just a job title, right?
Yeah.
It doesn't mean that you own the company. It just means that you're hired to run the company.
Yeah, there's people like that. There's plenty of people out there who would be happy and want to be in that position.
Yeah.
You know. You know, that's
some people that thrive on it. It's like
exactly.
I mean, you need the type of person that can work like, you know, like 80 or 100 hours a week. Like the people that are like so hardwired to do that they cannot sit still for 2 seconds, right? Yeah. That's the kind of person that should be a CEO. Whereas I'm not like that. I burn out a wee bit too quick. Sometimes I quite like having the the engineering projects and the a reason for doing something and the goals set quite nicely, so that I can just run with it and I can like do things in my own time. And I mean, I still work super hard, but it's like the idea of being a corporate CEO. It's like, no, probably not.
Yeah, it's good. It's good that we talked about it because I think you know, people like to hear this.
Yeah,
and I think as well, investors often get. I mean, at the end of the day, CEO or not, it's all about the main person
just
of
make
the
it
business.
work. Yeah.
So if an investor hears this, it's like, okay, I understand now what the position is with this guy and this company.
Yeah.
I'm happy to hear that because he's not somebody who's completely wants to do everything, and that's a warning
just
sign
like an egotistic founder type of thing.
Investors do not like that.
Yeah.
Because they may even be able to bring in a CEO or recommend people.
Yeah, of course, yeah.
Exactly, that's sometimes.
And then investors don't have to have that battle with like the person that's currently the CEO or the founder of the company. You know, they don't need to have that battle because like, I get it already. It's fine.
Yeah, it's cool.
Yeah.
Stuart Kerr, everybody, CEO currently and the founder of Rock Human Devices. Stuart, it's great to have you in the studio.
Yeah, it's been awesome. Thanks very much.
Well, thanks for coming and sharing, and wishing you all the best, and wishing you, the journey ahead, the real challenge. This is the big challenge for you.
I know.
The next few months. Like now, you're sort of head down, get this built. Then some bigger challenges as well, but it's all a learning curve for you. Let's put a shout out as well to your website so people can know what's the best way. How do you like people to contact you? Through the website, LinkedIn, or what are you good with?
So if you want to sign up for the user trials, you can actually go onto the website now. The website, there's a couple of words missing. There's a couple of spelling mistakes. I need to fix it. We've just moved over to Squarespace.
The chief website designer stroke CEO.
This company is brought to you by Squarespace. No. So go onto the website. My email address is stuart@rockhumandevices.com. stuart@rockhumandevices.com. So just reach out to me if you want to know more. I can let you know as much as I'm physically allowed to tell you.
And I'll have that conversation as well. I mean, I know you're not raising right now, but it's coming. People who are interested, partners, people who come from that. I mean, somebody might not come across and say, "Hey, I'm a CEO," but they may say, "Hey, look, I know this industry really well. Love what you're doing. I don't know the fit right now, but let's have a conversation or a coffee or whatever."
Of course. Yeah. I mean, if anybody wants to reach out to me for anything at all, like they've got hearing loss or, just like what you said,
We'll put all the details in the show notes.
Yeah.
Stuart, thank you so much.
No problem. Thank you very much.